Alright, what we're going to do today, absolute value functions, equations, and inequalities. With inequalities, we'll need colored pencil so we can do graph and set them on interval notation. We're going to start out with equations. Alright, this is the definition of absolute value that we have always looked at. Absolute value is the distance the number is from zero on the number line. But algebraically, this is the actual definition for absolute value, something you probably want to write down and remember. Absolute value is defined in pieces. Later on we will call this a piecewise function. And it's defined in different ways for different domains. And just to kind of get you back to thinking about functions and domains and stuff, remember the domain is what you can plug in for x usually. This is an A. But the range or the answers that you would get. So this is saying if A is greater than or equal to 0, and I take the absolute value of A, then A is my answer. What does that mean? Well, first of all, you got to look at this right here. What is one word that describes all numbers that are greater than 0? They are whole numbers, but they're positive. All right, so if I'm taking the absolute value of a number that is positive, then that positive number is the answer. On the other hand, if I'm looking at taking the absolute value of a negative number, something less than 0, for example, so I'm going to take the absolute value of negative 6. This looks like this is saying the absolute value is negative. In fact, it's not. This is an opposite. So this is saying if I plug in a negative number and take its absolute value, then the answer to that would be the opposite of, for example, this negative 6 would be a positive 6. So both of these are just making sure that you get a positive number for the answer. Absolute value is distance. It is always positive because it's talking about the distance of numbers from 0 on the number line. But this is the algebraic definition of absolute value, problem number 2. Alright, really quickly, let's just look at some problems like this. Now, absolute value symbols are grouping symbols, but they're different from parentheses and brackets and braces and all that stuff. You still do what's inside the absolute value bars first, but then it's not like the distributive property, whereas like if you have a negative on the outside, we've worked some problems like those today. We have a negative on the outside. You do take the opposite of a negative. So if I do what's on the inside here, I get 6. If there were a negative on the outside, my answer would be negative 6. That's really the only way absolute value can be negative is if the negative is on the outside. 2 minus 8 is negative 6. The absolute value from negative 6. Remember, if I plug in a negative number, the answer is its opposite, or in other words, I'm saying how far is negative 6 from 0 on the number line? It's 6 units. Again, if this had been negative, my answer would be negative only because of the opposite of the symbol. How far is 0 from itself on the number line with 0 units? Alright, let's look at these. What is 5 minus 14? Negative 9, what's the absolute value of negative 9? Positive 9. What is 12 minus 2? And the absolute value is 10. So don't think about changing the sign, of course, with absolute value. Remember that it's distance, so it's always positive. Any questions about those? Those are just real simple review type problems. Also this is an absolute value equation. Notice the variable is on the inside of the absolute value bars. Absolute value equations have up to 2 answers, okay? So here's what this is asking. What would I take the absolute value of and get 7 for its answer? Well, either x is 7 or right, x is negative 7. So there's my 2 answers. Either x is 7 or x is negative 7, because I could take the absolute value of either one of those and get 7 for my absolute value. So absolute value equations can have up to 2 answers. Now, if you have variables on both sides of the absolute value equation, it's important that you check your answers. This one doesn't have variables on both sides. This is obviously true. If I took the absolute value of 7 or negative 7, I would get 7. But if I had variables over here, and I plugged in my answers, if I had variables over here, and I plugged in a -7, and I got a negative number here, it wouldn't work, would it? Because I would be saying I'm taking the absolute value of something and the negative. So only when variables are on both sides, you need to check the range. All right, let's look at this one. The absolute value of 3x minus 2 is equal to 10. Well, what's in the absolute value bar that I'm taking the absolute value of is either equal to 10 or is equal to -10. Those are both possibilities. All right, now there's my two equations. Notice the word I'm using here, or, like with a disjunction, right? So I'm going to add 2 to both sides, solve these two equations. 9 by 3x is 4. Does that work? If I plug that in here, 3 times 4 is 12, 12 minus 2 is 10, absolute value 10 cents. That one checks out, that's good. Or over here I solved the same thing. Now notice what I did. This is not 10, this is the opposite of, there's my negative answer, or my negative number I could be taking the absolute value of. Divide both sides by 3, and x is -8/3. And here's why I say that improper is better than mixed. If I plugged in -8/3 right here, what would happen with those two 3's? They cancel. What is -8 minus 2? -10. What's the absolute value of -10? +10. So if you had made this 2 2/3, then what would you have to do to plug it in? Plug it in properly. Or we can always use our calculator too, right? That works really well. All right, but both of those check, so both of those are solutions. All right, let's look at this one. Why don't you try this one? Work ahead of me a little bit. All right, we're going to have 2 answers. I'm taking the absolute value of something and getting 8. So what will my statements be? Either 2x minus 4 is equal to 8, or 2x minus 4 is equal to what? That's right. All right, solve both and see what your answers would be. You guys agree with 6 and -2? The 6 check out, if I plug in 6, 2 times 6 is 12, 12 minus 4 is 8, absolute value of 8. What about -2? 2 times -2, -4, -4, -4, -8, absolute value of 8. So here's my 2 answers. Again, just like any equation, if you substitute it in, it works, you know you have the right answer, so you can assure that you're correct. All right, let's look at this one. How can I look at that without working it and know that this problem has no solution? How can I take the absolute value of anything and get a negative answer? Does that make any sense? So when you have an absolute value equation equal to a negative, you can just, without showing any work, say no solution. Well, what if I'm on the test and I just don't even notice that, and I go ahead and I say, okay, 5x minus 2 is equal to -12, and 5x minus 2 is equal to +12, and I start solving this problem out, and I get -2 for my answer. I'm going to get another answer on this side. So it'd be what, 14/5. Well, what would I get if I plugged in -2 right here? What would this give me? -10 minus 2 would be what? Come on, -12. What's the absolute value of -12? -12. I just took the absolute value of something. So hopefully you would see that when you plug those in, they would not work. Hopefully, actually, before you ever did any of that, you would notice that I have the absolute value equation equal to a negative. When you see that, that's a red flag. You say, no solution. Absolutely not. I can't take the absolute value of anything and get a negative. Alright, let's talk about inequalities. Greater than, less than, greater than or equal to, less than or equal to. This is the part you need to write down and memorize so that you'll know what's what to do, what words to use, and how to do the graph. Let you have a minute to write all that down. Okay, notice that with less than, less than or equal to, that you are going to write two sentences, a compound inequality. They will be in conjunction, so you will either write them as the same or you'll probably join them together with the word and. Which means when you graph them, you will be looking for the points of intersection. Just like with and, where we practice doing them above and below to see where the two colors intersected and all that stuff. With greater than or equal to, you're going to be graphing a disjunction. You'll use the word or. The graph will be a union. How am I going to remember that? I just have to memorize it some way. Well, I taught this lesson one time, and this class, they were struggling with remembering less than, greater than, or. I just couldn't remember. Finally, one day this kid says, well, I'm going to remember it because of the Great War. And I thought, what? What are you talking about? What is the Great War, by the way? Do you guys know? One. World War I was called the Great War. And then what happened? World War II came along, okay? And it was big. But he said, I'm going to remember the Great War. And I said, well, explain that. And he said, well, greater than is or. And it's just reminding me, I just think of that. When I say great war, greater than or, it sounds the same. And I said, okay, you go with that. But whatever it takes to make up something silly sometimes, and you guys, I'm sure, y'all are good students, you've done that before, make up something goofy, y'all made up a crazy sentence like, cats ate dogs, but dogs chase mice. That's the metric system, right? What's the one with the planets? Y'all remember something crazy about the planet?
Yeah.
Well, like PEMDAS, please excuse my dear Aunt Sally, what's that? I mean, it just helps us remember. Parentheses, exponents, and so forth. So that's what my student told me. I'm gonna remember the Great War, so greater than or. And I said, okay, you go with that. So that must mean less than. Now the way I say less than, it just sort of rhymes in my mind. So whatever it takes to remember, less than is and, greater than is or, and those words from last week should help us to remember how that will work. All right. So this was less than. So what word will I use? Less than what? Just write it down. And I just said it. Less than and. Okay. All right, I need to get what's inside the absolute value bar simplified here because I have double signs. I have the opposite of the negative. And so there it is simplified. If I were you, I would write every bit of this down, okay? That's just me. That's what I would do. All right, I'm going to write my sentence. And this less than, so I'm going to use and in between the two inequalities. Here's the first one. Now remember what I've been doing with equations? Let me go back for just a minute and remind you guys. And let me ask the question that somebody in here is going to ask me in a few minutes. Look at this equation we wrote. Y'all didn't have any questions about that a few minutes ago. Now let me ask you the question. So where did the absolute value bars go? Did you just cancel them out? Because I'm going to ask that. Where'd they go? They didn't go anywhere, did they? We were saying that absolute value of some number is 7, so what's the number? Well, you agreed that it's either 7 or negative 7, right? They didn't go anywhere. I didn't take them off or anything. I just wrote the sentence that tells us what the solutions were. So when I'm looking at this problem and I'm going to write the sentence that comes from it, the absolute value bar didn't go anywhere. I'm going to write the two possible solutions that it could be. So what's in the absolute value bars is less than or equal to 7, and less than is and. All right, let me call a timeout here. What's alliteration in literature in English? Alliteration. How many of you guys are taking English right now? No one. You are? You're the only one? All right, so do you guys remember from the 8th grade? What is alliteration? The same beginning sound. Yeah. Like tongue twisters. She sells seashells by the seashore. Okay. I have a hard time with those. Do you guys? Maybe y'all can do them. I don't know. Alliteration is the repetition of beginning sound, and I'm going to give you some alliteration to help you to remember how to complete this problem. Okay? Listen carefully. In the second sentence, switch the symbol and the sign. In the second sentence, switch the symbol and the sign. I'll write that for you. Alright, that's going to help us to remember what to do over here. Now, here's the first sentence. It looks just like the inequality does, the absolute value inequality. It just doesn't have the absolute value bars. Remember, I didn't cancel those out. Here are the two possibilities. Here's what two things can happen to make that true, just like with the equation. Equal what's inside either what's inside the absolute value bars is less than or equal to 2. And where did this and come from? Why did I choose and? It's less than. And on the second sentence, I switched this symbol. It was less than. I made it greater than. And I also switch the sign. So in the second sentence, switch the symbol and the sign. And that tells us how to write the second sentence. All right, now, pretty easy, just like last Thursday. I'll solve the problem. So far, so good. I'm stuck on my essay. Alright, let's graph it. Do set builder and interval notation. Y'all remember how to do those things? Alright, so let's draw us a number line. Remember, one less than the smallest number, one greater than the largest number. Alright, now and. Intersection or union? Intersection. So if you so choose, you could graph above and below the line. So let's say I'm looking at x is less than or equal to -3, so that would be going this way. And then if I said, okay, I'm going to switch colors, and I'm going to do greater than or equal to -7. Alright, where is there both colors, blue and black? Where is there both colors? Well, in between, right? So this is a mathematical sandwich in between -7 and +3. What do most conjunctions look like on the graph? Most of the time they look like a what? What is that? A line segment. Most of the time they look like a line segment. I didn't say all the time, but most of the time they look like a line segment. Alright, so set builder notation will be the set of x's such that, here's my smallest number. Here's my variable in the middle. Here's my largest number. My symbols are always pointing this way, just like less than symbols. And in interval notation, it starts at -7, ends at -3. Why did I use brackets? Because they're included. The numbers are included. They're colored in on the number line, so I need brackets down here. Right, that's my answer. So how much of this problem is new? Because didn't we do this part last week? Weren't we prepared by looking at conjunctions last week? We could do all this stuff. Agreed? So we can graph, we can do set builder, we can do interval notation. Alright, what would you say is the word we would use with this? And or? It's less than. And. Alright, would you write the sentences? Write the and sentences. On the second sentence, switch the symbol and the sign. Agreed? Cause that's a whole new part. Alright, solve them, graph them, do set builder and interval. Solve them each, graph them on the same number line. You're looking for points of intersection, do set builder and interval notation. Alright, so less than or equal to -2, greater than or equal to -10. Whoops. Where they're both colors, well, between -10 and -2. Looks just like what we would suspect. Looks like a line segment on the number line. And so, set builder notation is a set of x's. I have my smallest number, reading my graph from left to right. I have my smallest number, my variable in the middle, my largest number here. And my interval notation goes from -10 to -2. Agreed? Okay, I see people are racing and writing some things, so did we make a silly error, or are we all good now? Anybody have any question at all? Is this sort of new? Some yeses and some no's, alright? Gotcha. Alright, so greater than is what word? Or. I use the regular or, right? So let me write my sentence. X minus 6 is greater than 2, or on the second sentence, switch the symbol and the sign. On the second sentence, switch the symbol and the sign. Alright, that's all the new stuff right there. I did it. Alright, so let's solve. Let's graph. What do most or sentences look like on the graph? Not a line segment. Two rays going in opposite directions. Okay, let's see if that's going to happen here. I have a hole at 8, greater than. I have a hole at 4, less than. So set builder notation is the set of x's such that, and because what's on the graph is right here, I can just use this statement, x is greater than 8 or x is less than 4, because that's what the graph said. They didn't cover each other up, giving all little numbers, they're not going in the same direction or anything. So reading from left to right, this graph starts at -infinity, comes up to 4, but it's open because this is not colored in. Excuse me, and that little section is union with from 8 to positive infinity. And that's interval notation. Any questions about those? You guys remember that from last week? Just the compounding plot. Alright, write the sentence that goes with that. Write the sentence. On the second sentence, switch the symbol and the sign. Right, tell me what's wrong with this. What did I do wrong? Oh, I didn't make it negative. Well, I meant. Okay. Now what's wrong? What's wrong with that first statement? It's got absolute value. Can I do that? Can I solve a problem inside absolute value bars? No. No, no, no. We can't take that shortcut, okay? Our statement really says that x plus 7, not the absolute value of x plus 7, is greater than 3, or x plus 7 is less than negative 3 on the second sentence, switch the symbol on the sign. So it has to be the whole statement. Subtract 7 from both. I know we're all into shortcuts. Subtract 7 from both sides. Really, it's not that hard. Remember on your graph, you go one smaller than the smallest, one larger than the largest. Right, or. This is great. This is the good part. Or, we don't have to do above and below. We're not worried about where they intersect. We're just put down exactly what it says. So, greater than negative 4, less than negative 10. Again, there's what I was suspecting would happen. You got two rays going in the opposite direction. So this will be the set of x's such that x is greater than negative 4 or x is less than negative 10. This goes from negative infinity to negative 10. Union is negative 4 to positive infinity. Just looking at the graph. Negative infinity to negative 10. Union with this little section. Negative 4 to positive infinity. That's leaving out this in the middle when I put those two sections together. Telling you what the graph really says. Alright, questions? Easy stuff. We're ready for this test, right? We've got simple inequalities, we've got multi-step inequalities, and we added conjunctions and disjunctions with compound inequalities, and then we've got now we've got absolute value included too. Alright, you guys do the whole thing. Write your sentence. Solve, graph, do set, build, or interval notation. Alright, why did I choose this word? That's a whole new thing for today.
Because it was greater.
Because it's greater. Alright, do you guys agree with that statement? X is less than or equal to, or greater than or equal to 7, less than or equal to 3. So greater than or equal to 7, less than or equal to 3. So again, set build is pretty easy. So it starts at negative infinity, comes up to 3, and is included. So I need a bracket there. Be careful, watch for that. Union with, and then 7 is also included, so I need another bracket. Just positive infinity. Good deal? What's the answer to this? How come? If it can't be equal to a negative, how can it be less than a negative, right? You want to change one thing. What's the answer? What? Absolute value can be equal to a negative, agree?
It can be more than a negative.
But it can be more than a negative. When can it be more than negative? When is it more than a negative? All the time. All the time, right? Let me change this so I'm not going to get a fraction because I know you guys are allergic to that. Let's say. greater than means what? Or. On the second sentence, switch the symbol on the sign. Alright, work that thing out. See what happens. You guys are gonna let me do all the work. Work that out. Now I'm divided by a positive, so I didn't flip my symbol. And a negative 5 1/3 probably in this area right here. And it's greater than or equal to that. And then 4 is here, and it's colored in, it's less than or equal to that. So I'm going back over all this, but keep going. And what did I color in? The whole other line. How do I word that? All real numbers. Where does it go? From negative infinity to positive. How could I have known that without all that work? When's absolute value greater than or equal to a negative? All the time. Okay? Absolute value can't be equal to a negative, that's no solution. Absolute value sure can't be less than a negative, but when is it greater than negative all the time? Alright? Good deal? Alright, this is your assignment. Alright, this will be a 20-point assignment, because that's 10 points. And that's 10 points to make it worth your while, okay?